All right, guys. Hope you had a great break. So we're going to start a whole new unit. It's about functions and graphs. I would say this is one of the tougher units that we've done so far because it's kind of some new stuff. However, some of it's some old stuff. But domain and range get tied into here, and it can be kind of difficult at times. So with that being said, we're going to talk about whether a relation is a function. There's multiple different representations of that. And then we're going to evaluate functions expressed in function notation. So a relation can be expressed in a variety of ways. There's a table that lists the ordered pairs, a formula equation, or a graph. So here's a couple examples. So it says for each relation, identify the domain and range. Well, don't forget, domain is the x values. Range is the y values. So if they give you a mapping diagram like this right here is going to be your domain. This is going to be your range. So when you list it, you would say domain, say 0, 1, 2, 3. That's your set. And the same thing with range. My set would be -2, 1, 2, 4. All right? Sometimes they'll give you a table like this. However, this one, they tell you what the domain, well, what the x values are, aka your domain. So that's 1, 2, 3, 4, 5. And your range is 1, 4, 9, 16, and 25. All right? So that's just a nice review of domain and range. Domain is the x, range is the y. You need to know that. So definition of function is a correspondence from a first set called the domain to a second set called the range. In order for it to be a function, the x cannot repeat. So that's kind of what this is saying here, but I'm going to simplify it. I'm going to say x can't repeat. So it says determine whether each function or each relation is a function. Explain why or why not. There's an example I'm going to talk about from the Hawks. It's kind of confusing, but that's besides the point. So this first one, they give you a set of ordered pairs. So 2, 5 is 1, 3, 5 is 1, 8, 3, and then -4, 7. So all I need to look at is the x values to determine whether it's a function or not. So my x is the first value in the coordinates. So 2, 3, 8, -4. One of them repeats, so this is a function. So it's a function. And you would say why? Because the x doesn't repeat. Then the next one, same thing, they give you ordered pairs, 2, 5, 4, 5, 2, 3, and -4, 5. Well, if you look at that, 2 shows up twice. That's a repeating x value, so that's not a function. And you would say, why? Because the x repeats. Now, the example on Hawks, it talks about brother and sisters, peoples, and parents. So when it says domain, it really just wants to know, like, did they say brothers or sisters in the problem? And then range is going to be people of, like, with sisters or people with brothers, or vice versa. They'll say females and males for the domain, and then it's parents with girls, parents with boys. So I just wanted you to like recognize that problem is just a domain and range problem. All right, and don't overthink it. Just select the one that you probably think it is. If you need help with it, just reach out to me. It can be kind of confusing, but that'll be on the next homework assignment, not this one. All right. Another way to determine whether it's a function is not only that the x repeats, but a vertical line test. So if they give us a graph, we can draw a bunch of vertical lines, and if it hits that graph, so this diagonal line we have right here, more than once on any vertical line, then it's not a function. But if you look at this one, you see every vertical line only hits it once, so that's a function. So that's the vertical line test. Same way here, if I draw a vertical line, it only hits it once, right? At those vertical lines, so that's a function. The one that's not a function is the last one, because if I draw a vertical line, any vertical line, you see how it hits it twice? So that's going to be not a function. So that would fail the vertical line test. So those are the two ways to determine whether it's a function or not. Another thing says determine whether each equation defines y as a function of x. All you're doing here is solving for y. All right, so I'm going to get y by itself and solve for it. In order to do that, I'm going to add 3x. So I'm going to have x squared plus 3x minus y equals -2y. And then I'm going to add y. So that's going to become x squared plus 3x equals negative 1y, and then I'm going to divide everything by negative 1 to get y by itself. So my final answer is y equals negative x squared minus 3x. Now if I said, hey, evaluate for x equals 2, you're just going to plug in 2 for the x, and you're going to solve it. Now be careful of your signs. If it's negative, that doesn't apply to the 2. So it's going to be 2 squared, which is 4, but now it becomes a negative 4. And then it's minus 6. So if I evaluate that one, it's going to be negative 10. All right. B is another example. I think you can do this one by yourself, so I encourage you to pause the video. I'll probably have a question here, and just try it. So try and get y by itself and solve the problem. So this one, add 5x. I'm going to subtract 2y. I'm going to divide by negative 5. Now, same thing here. If I said evaluate for x equals 2, you're going to plug it in and solve it. That'll be my question. Can you solve it for x equals 2? Next one, this one shows up on the Hawks. It's kind of a difficult one because people don't know what to do with the square root. Well, instead of squaring both sides, just subtract the whole square root. I know it seems kind of weird, but that is one big term. So my answer could literally be this. Y equals negative square root of 1 plus x. If you subtract it to the other side, minus 2. And then if I said, hey, solve for x equals 2, you'd plug it in and solve it. All right? So if it ever says determine whether each relation or each equation defines y as a function of x, all it means is to solve for y. That's all you're doing. Moving on. Now this is the last part of this lesson. I would say this is one of the harder parts. So we do have a function in equation form. We have special function notations that can be used. We use a letter to denote the name of the function. We write this notation as like f of x as an example. So this one became f of x. F of x is the same as y. That's what I wrote right here. So y equals f of x. Just means the same thing. So what they're going to do is they're going to give you an equation, and they're going to say, hey, now solve it. So this one says f of 7. So what that means is I'm going to plug in 7 for every x that I see, and I'm going to solve it. So I get 7 squared, which is 49. 2 times 7, which is 14. And I'm going to add 7. So 49 minus 14 would give me 35, plus 7 would give me 42. So f of 7 for that function is 42. And every function is different. Now here's where they tend to trick you. They're going to throw in letters instead of a number. All it means is to plug it in. So if I say f of c, I'm going to plug in c for every x. That means anytime I see an x in my original problem, which is f of x equals x squared minus 2x plus 7, I replace that x with a c. So this is going to be c squared minus 2c plus 7. And sometimes that's all you can do. All right? You don't have to, you simplify as much as you can. Just depends on the problem. C is kind of a tough one because it's x minus 1. So again, when you plug it in, you're replacing x with x minus 1. Now the thing that sucks about this one is you have to FOIL because it's x minus 1 squared. So I'm going to FOIL it. I'm going to get this. I'm also going to distribute right there. I get that whole long thing. Now I'm going to go through combine like terms. So I'm going to get x squared minus 4x plus 10. Again, I know that's a lot, but that's just what you have to do. All right, try this next one. If you can do this one, this is one of the harder questions on the Hawks, then you can do anything. So I replace the x with x plus a. I have to FOIL here. Go through and combine like terms. Well, if you look at it, you can't combine anything. So that is my final answer. The hardest part is remembering to FOIL the x plus a. And then lastly, kind of end on an easier one, f of x squared. You're still squaring it. So I'm going to get x to the 4th minus 2x squared plus 7. Okay? And then lastly, I threw in one extra one. That'll be for the people that are in person. But this one right here at the bottom. So they're going to give you a function. And then they're going to give you this whole long expression that I started with, the f of x plus h minus f of x over h. Now what I want you to do here is I want you to replace the x for what it says depending on the expression. So this x plus 4 is going to be the first one. So I'm going to say x plus 4 minus 1. So that's just that first part. So what I underlined in red is just the first part. Now the second part is minus f of x. So I'm going to say minus. I'm just plugging in x, but you got to put it in parentheses. And the third part's h. So I'm just going to say over h. I don't know why I wrote x plus 4. That should be x plus h here. Sorry. Okay. So now we're going to solve it. We're going to get 4x plus 4h minus 1 minus 4x plus 1 all over h. If I combine like terms on the top, 4x minus 4x cancels. 4h is left. Negative 1 plus 1 cancels. So I have 4h over h. Well, h divided by h gives you 1, so the answer would just be 4. Guys, this shows up on the Hawks. It's going to be a number. You have to be able to look at it and be able to solve it. I know these are tough. They're not easy. So just as some extra practice, I threw in this last one as a hard one for you guys. You can try these. I'm not going to work all of them out. I'm just going to do this last one. So when you're doing this, again, it's in parts. So I would do the x minus a part first. So I'm going to say 2x minus a squared minus x minus a. Minus, now I got to do the second part, 2x squared minus x. Well, if you notice, I have to FOIL, so it's going to be 2 times x squared minus 2ax plus a squared minus x plus a minus 2x squared plus x. So now we distribute. And then I'm going to combine my like terms. Well, if you notice, the 2x squared's canceled. The x's cancel here. So anything that's underlined is canceling. The rest of it's going to stay the same. So I'm going to say that would be my answer. 2a squared minus 4ax plus a. Again, I know these are tough, but they show up on the Hawks. You have to think about it in sections. The red part is its own section, so I used the function they gave me, which I'm underlining at the top, to rewrite the red part. But then the g of x is another different part. So I got to use the same function, but rewrite it this time with x instead of x minus a. Okay? If you guys have any questions over this, please let me know. That is 5.1. It's going to be paper homework, but the next Hawks that I'm going to assign after this next lesson is going to have these types of questions on there. Okay? Have a great day, guys.